So we're just going to start talking about control. I started the recording a little bit late, apparently. So we're talking about control phase activities, and I guess let's blackboard it. So what are the different types of control phase activities and tools? Okay, so I'd like you to let's take 15 seconds, and I'd like you to write down on a piece of paper, right? Don't just write it down in the blank slate in your head, but write it down on a piece of paper if you got a pencil. Write down 1 or 2 or 3 activities that need to take place in the control phase. What are the things that you need to do to make sure that your improvements are sustained? Okay, I'd like everybody to do that. Take an additional 15 seconds. Okay, let's go around the room, and I'm going to put a couple of people on the spot, I guess. Let's start with Shani. What's an activity?
I had policies and procedure development.
Aha. Develop P&Ps. Okay, and some people say SOPs, right? Very similar. Very similar. Okay, excellent. Jim, I'm going to put you on the spot now. What's something that you had written down? Hello, Jim. Okay. I'm hoping that not everybody's put on mute. I'm going to move on to Patrick. Are you there?
I'm here.
Excellent.
I put some type of dashboard or visual measurement.
Okay, dashboard, visual measurement. Okay, got it. Okay, good. Now you might want to think of that as maybe more of a tool, right? But measurement is that can kind of go either way. I'm not going to make too much of a bother on the distinction. I'm good with that. All right. How about Sue? What's something that you had?
Sue just stepped out, Mark.
Okay. Brad, what's something that you had?
I kind of missed the question, but I think I got the gist of where we're going.
Okay.
I think one of the activities that you want to be doing at the control phase is asking, did you actually fix the problem, or is it on track? So some sort of mechanism to get the project back on track if you're running into problems.
Okay. Yeah. So okay, that makes some sense. I'll put that in there. Maybe let's call it monitoring, right? I think the assumption, at least to a certain extent, and there's a little bit of gray area, right? So whether or not you consider the evaluation period part of the improved phase, I happen to consider it to be part of the improved phase. So if we don't actually make sure it's worked, then I think of that as kind of evaluating whether it's worked, right? And you know, I think you can. It's equally valid to say that deserves to be in the control phase or the improvement phase. I just happen to put it in the improved phase, and you'll find it there in the navigator. So in the control phase, there's no question that you'll need to be tweaking it though. So to say, yeah, in a lot of cases you'll find something like, yeah, it worked, but it didn't work as well as it could, or you know, we're not sure that it's going to sustain or I'm sorry, be sustained and work. So that's excellent. So monitoring whether you do it in improve or control, definitely want to make sure it keeps working. Okay, Tracy?
Well, I had a couple of I think, similar things as everybody else, but where I see that we tend to a lot of times fail in executing in the control phase is making sure that she said policies and procedures, but making sure that the new process is hardwired in through the infrastructure in terms of, you know, new people coming in know what the new process is. People get validated on the new process, and we check back on it frequently. That's a lot of words. I'm not sure that I covered what.
So I like that. So some people say hardwiring is either standardizing or socializing or institutionalizing or whatever. Hardwiring is a great word for that. Whatever works, in your organization. And then I love this idea of, yes, you need some training and testing to make sure as we get new people coming in that they follow the PMPs, right? That there's a procedure that handles how personnel are entered into the process as well. I think that's great. All of those things have to come in into the control phase. There's plenty of other things too, and we'll kind of cover those things as we kind of walk through. I don't think.
Hey, Mark?
Yes.
I'm sorry, you asked me a question, and I had you on mute.
Oh, okay. Yeah, Jim, do you have another one that you'd like to?
Well, I answered you, but I didn't know I couldn't be heard.
Okay.
And
Yeah.
what I was looking at, my answer was to your control plan that everybody has to be in total agreement with what the new controls are going to be. So to have that in agreement before you launch the plan.
Mm-hmm. Yep. Yeah, so we'll talk a little bit about that. So I'd like to talk about just a few tools, but if you would just take, now I'd like to ask you 15 more seconds, okay, and I'd like you to just list all the tools that you think that you might use in the control plan of a project. Now, the tools are tactical, right? So an example of this might be a dashboard. So Patrick was kind of on the fence on that because dashboard's kind of a technique and tool. But in this idea of visual measurement, that's certainly more of an activity. It can be viewed as an activity as well. But I'd just like you to list as many tools or as many specific tools that you can think of that you might use. Okay. Don't expect to be comprehensive here, but let's kind of walk through again. I'm going to start in reverse order. I'm going to start with Jim this time. Jim, what's a tool that you might use in the control phase? Specific.
I think
Okay.
it would be, I guess it would be some kind of experiment to see if the controls really do work. So, you've come up with this control plan, and now you're going to implement the control plan. So,
okay. Let's say designed experiment.
yeah, I was struggling. I'm not so sure that was it, but
Okay. Well, it's
yeah.
an idea, right? It's an idea.
Yeah.
Let's move on. So Sue, what's one that you had?
I have control chart.
Control chart, you bet. Okay, so control chart's definitely going to be a tool that's going to help you in the control phase. Okay, Patrick, what's one that you had?
Could it be something as simple as standardized checklists?
You bet. A checklist is a great tool. Right, a standardized checklist, great. Tracy, what's one that you had?
I like using the either flow map, flow chart, swim lanes, whatever terms you're using that in educating, in the hardwiring, training, testing, developing the policies and procedures. I just think the picture and what everybody goes through to develop that is something that all the other people that were involved on the team, they can relate to that.
You bet. You bet. Yeah, and you can use and in this case, you'd want to use the new, not the as is, right?
Yeah, hopefully you pull the right one out.
That's right. That's right. Okay, excellent. All right, Brad, what's one that you had written down?
Well, one thing we're using in our discharge project is a simple whiteboard. So it's kind of like a public version of a checklist, but with very clear areas of responsibility. So, yeah, some sort of visual control that outlines who needs to be doing what.
Yep. Okay, excellent. So it's maybe for roles, right?
Yes.
Visual
Yeah.
board for roles. Okay, great. Yeah, I love that. I love that. So those are all great ideas. And, I'm going to give Jim another chance if you want to add one. You have one to add. If you don't, that's
Apparently you didn't
totally
like the
okay.
one I had, huh?
Well, if you don't have any, that's okay. That's okay too.
Well, I'm thinking, around the fact that you're going to put this in, and you have to have some kind of a feedback to let just to let you know that
Yeah.
the new things that you're trying are actually working, or the direction that you're going in.
Yeah, you got it. So let's say a monitoring plan. Oops, a monitoring plan. Right? So a monitoring plan can, for example, lead to a specific dashboard, or it could be something different, right? It could be, for example, suppose one of your solutions was a 5S solution, right? Where it's like, I'll try and be in Jim's world here for just a moment. So you've got, say, a manufacturing plant, and you've got an area where people keep their tools, and you know that that's usually a mess, and one of your solutions is to apply a 5S solution to that. You might have a schedule that says here's how often we monitor it, right? So that might be an artifact that's in a control plan, literally a time schedule, so that we can say, hey, we checked it on Friday the 22nd, and all is well. People are following the procedures, right? If I'm thinking about it, it's like, I don't know, I haven't been in one of these fast food restaurants in a while, but it used to be when you go into a McDonald's bathroom, they had a sign up that would say, last time the bathroom was checked. I'm not sure if I believe those signs, but that might be the idea, right? Okay, so that's a great idea. All right, so what we're going to talk about today, we're not going to rehash, I won't say rehash control charts, but there is a section called Process Monitoring beginning on slide 25. We're not going to cover that. It covers control chart use in and after the control phase. But now just think about it. You're using control charts in a slightly more in a much more proactive way, I should say. Excuse me. Now to catch things as they go out of control. So presumably you know a little bit more about the process, and you can be more specific about that. That's covered in slides 25. There will be an online lecture for that. We will talk about a couple of tools in the first section, which starts at slide 2, which is on standardizing. And these are not exhaustive tools, but we'll talk about error proofing. We will talk about very briefly about 5S. I'm not going to say much about that, but 5S is a great tool. We won't talk about some of the standard checklists and things like that, but then we'll also talk just a little bit about visual boards. Okay, I'm big on the visual boards. Love that stuff. I think it's great. So we'll talk about that. And then we'll cover, I want to cover just briefly, I want to cover number control plan, no, number 40, starting at slide number 40, some stuff on control plan. And what I really just want to talk to you about is kind of, here's an idea and a template that I've used effectively, and a number of my clients have found helpful. You might want to use it and adapt it. Don't feel that you need to be a slave to it. It's really just an outline for, here are some of the things that I would think to put in just about every control plan. Okay, so we'll talk about. I'll show you what that looks like. So we'll cover those things. I'm going to cover them pretty briefly because I think most people are going to be pretty intuitive about all that stuff. Hard thing in control plan is really, it's sort of like it's getting it done. It's doing the paperwork, you know. It's tough to get motivated to do. The team has already finished a lot of things, and it's hard to keep going. All right. So let's cover this fairly quickly. So I want to start out with, oh yes, and before I go into this, these are sort of again, at a high level, this is what I would say are the activities that you really need to be thinking about in the control. You really need to be thinking about putting together a monitoring plan, standardizing your improvements, putting together a control plan, communicating the benefits of what you've just done, and recommending future improvements and closing out the project, which might mean reward and recognition. It should mean reward and recognition. It should mean some sign-off. It should mean some standard place where the data are put. It should mean a number of things. So use this as your guide. Before I forget, I also wanted to remind you that you do have this as a standalone, the DMAIC Navigator. And if you forget what some of the tools are or some of the key things to do, you can actually look at this, and it'll tell you, at least give you some idea for what are some of the things that you might want to consider using in the control phase. So, for example, putting together a monitoring plan, I need control charts, I need to think about sampling. How do I collect the data for my control charts? For standardizing, I might think about 5S or visual boards or error proofing or updated process maps. I think many of these things came out for the control plan, SOPs, control chart, and so forth. Okay, so that's just that's a tool that you should be able to. It's okay to cheat. It's okay to pull that out. Okay, let's kind of talk through this. We are on slide 4 in here, and I'm going to fast forward to. And you can see we have some things about standard workflow in that. But I want to talk about error proofing. And for those of you who used it, actually I'll just ask for a volunteer, anybody who would like to volunteer, their definition of what error proofing is. I'm sure it's probably pretty darn close. It's called, sometimes called mistake proofing, sometimes called poka-yoke, and it used to be called idiot proofing, which I did not like that term. But anyway, I guess I'll just ask people for if anybody would like to volunteer their definition for what error proofing is.
I'm up for this, Mark.
Okay, go for it, Jim.
When I think of error proofing, I think of go, no go. So it either goes or it doesn't. So an example of this would be a gauge. You're either correct or incorrect. It fits or it doesn't fit.
Okay, got it. Yeah, that's a good example of of error proofing.
So you know, I think of error proofing, mistake proofing, and yeah, I came up during the time when we said idiot proofing, and I never cared for that either. I used to like to think of it as you take the emotion out of it. It's just an exercise, and either makes it or it doesn't.
Yep. Okay, good. And, you know, Brad earlier said in the conversation, you know, that's kind of where we test out some of the improvements that we make. Error proofing, I think, is part of the application of that testing. So as we're rolling out changes in, say, a form, guess what? We're going to find out how people fill it out incorrectly, even with our best intentions. And we've done some pre-testing. When we roll it out company-wide, we're going to figure out where people type in a 0 instead of an O, or where people think that you can put 1.45 children instead of 1 or 2 or 3. And, you know, we're going to find out those things. There are lots of examples of error proofing from garage door in everyday life, from garage doors that don't close, to computers where Control-Alt-Delete you have to hit in order to accidentally shut down a computer. You have to hit multiple keys in a very deliberate fashion, so it's not likely to happen. To drop-down menus, lots of examples of error proofing in the world. It's very common. The basic ideas of error proofing are, and I'm going to come back to this in just a minute, is if you have something that you need to error proof, think of it in these 3 ways. First, figure out if you can design it so that, let's go with our form example. Design it so that it can't be done incorrectly. So a good or a reasonable example of that, I know this is getting old, but I know for some of you guys you won't remember this, or gals, is with when they came out with unleaded gas, and they used to have leaded gas. What would happen if you tried to put leaded gas into an unleaded gas container or into your car? It wouldn't work because it wouldn't fit in the nozzle. So you couldn't make that mistake of putting leaded gas in an unleaded in a car that only took unleaded gas. That's
But you know what, Mark? You could put diesel fuel in your gasoline tank.
Yes, that's right. So there's lots of different things that you have to decide whether you want to air-proof or not. So that might have been, for example, one of the things that they decided not to, or they decided it was too difficult to do, or whatever.
Well, they changed it now, but yeah.
Okay. All right. Okay. If you can't do that, or if it turns out that that's too costly, design it so that it can only be done in one way. So drop-down menus are a good example of that. If you're entering an address, maybe they have a drop-down menu for your state that says NY, and that prevents you from typing in all sorts of crazy things. Like I happen to live in New York, so I use a drop-down menu. It's going to come up with capital N, capital Y, and then that data flows throughout the system. I could, if it were a free-form text field, I could type in capital NEW space capital YORK, or I could type in the word New York without any spaces or without any caps or anything like that. Or I could misspell New York, or I could type in something else. So there's only one way that it's done, and so it keeps the data relatively consistent. Having said that, there's no check in many places about the state. What if I live in New York and I put in Mississippi? I just happen to do it. Well, it's not full airproofing. It just kind of designs it one way. So that's one way that it can be done. And the third way that it could be done is if you can't do either of the first two, you can't design it so that it can't be done incorrectly, and you can't design it so that there's only one way. You design it, if it's done incorrectly, immediate feedback is given. So I don't know how many of you are hockey fans, but in professional hockey, if the goal actually goes in, what happens?
The light, the buzzer.
Yeah, that's right. You get the red light that flashes, right? So on many internet forums, for example, what happens if you put in a field incorrectly? If you put in your phone number and you put in, say, alphanumeric, that's for your phone, and you put in A27QZX, what happens?
You get a pop-up or like the little red asterisk.
That's right. It comes back, and it usually tells you you're invalid, and then you're a nincompoop or something like that. It's not often done nicely, but it does come back and it says here's where it's done incorrectly, or maybe it colors red the fields that you forgot to fill out or that you filled out incorrectly. So those are the different ways, and that's kind of the philosophy of error proofing. Now, one of the things that I have found very helpful, here are some examples. Garage door, these are kind of old, but garage doors that sense objects. Grounded electric plugs, right? There's 3 prongs, so you can't plug it in upside down. Whoops, sorry about that. And screw up the polarization. Computer restart with Control-Alt-Delete, and so forth. Okay. One of the things that a lot of times you'll find with error proofing is you'll run into something where people where when you're brainstorming, how can we improve this? People say, well, it's just human error, or it's just there's no way that we can fix it. What I have found that when you get to that human error piece, on slide 11, I have some examples of things where you can where you may be able to redesign things and get beyond that. Well, it's just human error. Richard McInnes came up with this list. I didn't, but I've used it to effect. So, for example, symmetry. If you have a part or a form or a procedure that is highly symmetrical or is highly asymmetrical, a lot of times that can be an issue. So consider this. Suppose you had a form which was almost the same on both sides but not quite. You're inviting people to just copy one from the other. So maybe you want to do something to break up the symmetry, put a block on the top and a block on the bottom on the other side so people visually see that it's different. And anyway, here are some other things that people can think about. If I have a high volume, if I have people doing constant repetition, what might be a practical solution if I have people that are doing repetition all day, every day, and that's why they're making mistakes? What might be something that I could do?
You could rotate them to a different job at a certain point.
Perfect. Yeah, great. Or I could limit the amount of time that they're able to do this one particular job, or the number of pieces, or whatever, and so forth. Poor environmental conditions, lots of adjustments, mixed or many parts, many steps, infrequent use. So anytime you see these, they should be a red flag for that errors are probably going to occur if you have people doing it, and it should give you an idea for how you might fix it. Okay? All right, I'd like to take just a little bit of time, not a lot of time, but a little bit of time talking through given on the back, and we'll come back to the exercise, not this exercise, exercise 1. You'll do this in the homework, but this one right here. So I'd like us to brainstorm, what would be some error-proofing solutions that we could do in this case. So the backdrop is this. As in many companies, they use reusable envelopes that occasionally contain sensitive information, and occasionally they're not being emptied, and it causes major embarrassment and risk. So I guess in the hospital, maybe it could be internal communication between doctors or who knows what. Actually, this example comes from a former employer of at least one of you in here, of things that were being transferred by internal mail, and sometimes very embarrassing things left in there. So I'd like you to think about, and I know many of us are alone, but I'd like you to take out your piece of paper, and really take out a piece of paper. I know not everybody takes this to heart. Take out a piece of paper, write down 1 or 2 ideas of maybe what you could do to error-proof this. Make sure so that you could eliminate the this embarrassment. Okay? So take out a piece of paper, write it down, and then we'll go around the room and see what we came up with. Okay, remember, no wrong answers in this one, right? There are no wrong answers when we go around the room, so no fear. We're among friends. Okay, so I'm going to go back to our virtual whiteboard, I guess. Yeah, go to the whiteboard. And I'd like to kind of go around the room and get people's examples. So error proofing. Envelope. Okay, so let's go around the room. So Tracy, what was an idea that you came up with to error-proof this particular process or this particular situation?
Putting holes in the envelope or making one side clear or something like that.
Okay, and I'll put those as 2 ideas.
Sorry.
Right, those are 2 different ideas, so I like to list them separately. That's cool. That's great. I had the whole idea written down, but I didn't have the clear idea written down. It's good. Okay, Shani, what's an idea that you had written down?
Sue and I came up with redesigning the envelope so that it actually opens up from the center, so that sort of like a button in the center with ties or something, so that when you open it, the only way you can close it is knowing that there's nothing in there, because you would actually see it. It's completely exposed.
Got it. So it kind of looks like this, and you open it from there. Is that right?
Correct.
Got it. Okay. Interesting. All right, Brad, what's an idea you came up with?
Well, my thought is can we just get rid of reusable envelopes because they're probably pretty cheap?
I had that one written down too. That's a great one. I love that one. Yeah, can we just get rid of this? I have to admit, that's a really clever open up from the center. That's a very clever idea. But hey, can we just get rid of the reusable envelopes? Good. Okay. Patrick, did you have one that's not listed up here?
Yeah, the only one I got left, maybe some type of checkbox where kind of an in, out, where if you put something in there, you've checked the left side, and that way, if it's not, have a matching check on the right, you don't throw it away.
Okay. Got it. Got it. And you see how these, essentially these examples, oh, I didn't ask Jim. Jim, do you have one that that we don't have up here that you'd like to add?
When you open the envelope and you open the flap, what's inside is attached, and you have to rip that off.
Design with contents attached.
Right. So, and it's reusable. You know, it's just kind of like a sticky note. But when you open it up, and you have to tear it off, and
Got it.
And then the other item I came up with was some kind of acknowledgement that you have to either punch a hole to close it. If you don't do it, something.
Got it. Yeah, so I like that, and it's kind of similar to the checkbox, but it's a little bit different in a way I'd like to talk a little bit about. But what I wanted us to notice is that we're coming up with different ideas that are either now let's go through put the holes in the envelope. I mean, this was Tracy's idea. I don't want to take Tracy's idea, but this was one that I also had written down, and this is good. But couldn't I, even if there were holes, put it through without thinking? I could, right? So it helps me prevent it, but it doesn't necessarily prevent it. Whereas if I get rid of the reusable envelopes altogether, maybe the cost is minimal, and that may prevent it completely. Or if I design something where it opens up from the center, or where the contents are attached to the opening function, like I can't possibly open this without or close it with and put the contents in with that close, maybe that would be something. And it's just, exactly what you do is dependent upon your situation, the amount of severity it is, and the cost that you have to fix it, which kind of points out that FMEA is a great tool that can precede error proofing, right? So if you find that there's a situation in a process or in a product which happens to be highly risky, might be a good place to consider error proofing. Okay? I don't want to overdo this because I think that we kind of naturally understand these things. So the short thing kind of going out on error proofing is, use your previous tools to help guide what you need to error proof. You've got this idea of first try and make it so that it can't happen wrong, then so that there's only one way to do it, and as a last resort, try and give at least feedback when it is wrong. With the checkbox and in-out, again, great idea. I'm just reminded of the Raytheon solution. I used to work at Raytheon where we did a lot of secret. It wasn't all that interesting, let me tell you, but it was confidential and secret information, and we worked in a secure printing room, computing room, and what the in-out amounted to was essentially who to blame when something did go wrong, and so people stopped using the in-out very quickly when they realized that whenever anything went wrong, it was the people who followed procedures that got punished, not the people that didn't. Just kind of be aware of how those things can play out as well. All right. I am going to move on, but if there are any other comments or questions on error proofing, like to have them and talk about them. Now's a good time to do that.
You know, Mark,
Yeah.
your comment about the people that follow procedures were the ones that were punished,
Yep.
and I see that a lot. And you know, I don't know how you get around that. It's a big problem, though. It's a big challenge.
Right. Well, we talked about that a little bit in the lecture last Tuesday around the behavioral techniques, right? So designing and building reinforcement and feedback strategy when you're designing a process, that's a key thing. You want your
yeah, it makes me think about applying air proofing to that very point that, you know, there's no way that the people that follow procedure get punished.
Well, again, I think it's very difficult to say there's no way, but yeah, I mean, you may that may be a great way of doing that, is to apply air proofing to that. And if it's a key behavior, right? If following a certain procedure is a key behavior that you're really relying upon to get your process improvements, you may want to do a full ABC analysis on it to really understand the consequences that are there, and the consequence profile, if you will, whether people are going to get nicked or picked. You want to design in picks for doing the right things and design in potentially nicks for doing the wrong things. What you don't want to have is picks for doing the wrong things. You know, I do the wrong things and I get rewarded.
I've seen that too. But you know, this reminds me of that old saying, "No good deed goes unpunished."
Mm-hmm. Yeah, you bet. It's an area that's really ripe for improvement, and we shouldn't expect that we ever get it perfect. But I think that, you know, this is a great discussion, because it shows you when you go into a process, so many things that you can do using what we've covered in this. I'll tell you, those behavioral tools, some of the best tools that are around for running.
I know you've seen this too, and I'll shut up after this comment, but I've seen this particular area right here bring down an entire really great Six Sigma project. Just bring it to its knees.
Error proofing?
No, the people get punished for following procedure.
Oh yeah, yeah. Well, look, I mean, it's a serious thing that we need to think about in any project, not just from sort of the angle that we're talking about right here, which is sort of like, if I do the right thing, I get really punished by, I literally get punished by management. But even some of the process improvements that we make sort of have natural consequences that are not amenable to the people that are performing the process. So, for example, if we simply make an improvement on efficiency, what it might mean locally is that people get rewarded by finishing by getting more work. And a lot of times that's not what people want. So we have to think about, you know, how do we want to reward people for being more efficient? Just giving them more work is probably not a good reward. So we want to think about process improvements that way. All right, great comments. You know, and it jogged my memory about one other thing I want to talk about with error proofing. Error proofing is great, love it as a technique on its own. It goes very well with some other techniques, and one of those is non-value-added value-added analysis. Okay, and I think we're going back to the whole lean lecture that we had before. Non-value-added and value-added analysis is important to consider before error proofing. Why? Well, I've been to places where they would choose to error-proof things instead of getting rid of these non-value-added things to begin with. And essentially, when you error-proof something that's already non-value-added, you're just adding additional cost onto something that's non-value-added. So if you can, do a non-value-added, value-added analysis beforehand. And that could be looking at a process map, eliminating steps. You know, we often give terms to things that are just things that we do naturally in a process improvement. Okay, great discussion. Great discussion. Okay, I want to talk just briefly about 5S because we've covered it before, and again, remember that the 5S. Let me go back to where this is in the book. It starts on slide 15. We're talking about slide 15 right here. So if you want to flip there, the 5 S's are sort, set in order, shine, standardize, and sustain. And I don't think that you'll find any problems with 5S. We already covered this earlier. Here's an example of what 5S might look like in a shop. But there's lots of different things that you can 5S, from shared workspace to your email inbox. Lots of different things that you can 5S. And you can do a lot of 5Sing at home. The comment I wanted to make was that 5S is something that's often done as 3S. You get it cleaned, but it's not, to what Tracy said earlier, it's not systematic, so that it's not standardized how it's cleaned, and it's not, and we don't get that sustain because we haven't put in procedures to monitor and to socialize it so that everybody does the right thing, right? When somebody comes in, when a new person comes in, they don't know the right 5S procedures. So 5S does include those last two, which are standardize and sustain. Okay? I guess I'd like to get any comments on, before we go to visual boards, any comments that anybody has on 5S. We covered it before, so I'm not going to go over it too much. Great tool. Okay. All right. Very helpful tool. It's fun to do 5S too, for a lot of folks. It's not fun to get rid of stuff, but it's fun to, if you're on the improvement team, because you get to see the improvement day by day. Okay. So I wanted to talk finally a little bit about one other tool, and that is, and that's something that I would like everybody to think about when they create, when they're creating a control plan, and that's to create visual boards. So visual boards, I like to think of as posters or whiteboards that exist in a physical workspace that communicate all sorts of things. They can communicate goals, they can communicate vision, they can communicate current performance, they can communicate current initiatives, they can communicate operational type things like how much WIP do we have, how much work in progress do we have, sorry, and things like that. Now they can be virtual, but what I've seen with the virtual ones is they tend to remain in the virtual space unopened. And so they don't socialize as well as what I've seen. Today, we can probably do a lot better. In fact, I've seen quite a bit better, and I've designed some stuff that I think is better using flat screen monitors and all kinds of stuff like that. So we can move the virtual onto the public by doing that. Anyway, there's lots of different reasons to use that. One of the reasons why you can use visual boards is, you know what? Why don't we? First of all, I guess I'd just like to get other people's comments on this. So, does anybody else have any comments or questions that you think would be helpful to discuss? Things that you found helpful, or questions that you might have? Things that you found helpful when designing visual boards.
Yeah, keep it
Mark,
Oops,
I've been on
I'm going to take. Let me take Brad. I think it was Brad who was going to make a comment. I'll take that first, then we'll come to you, Jim. Okay?
That's right.
Okay, go ahead, Brad.
Yeah, I would say keep it simple. I know a lot of the visual boards we use, they tend to grow more and more complex to the point of being virtually unusable.
Yes. Yes, absolutely. One of the things, I think that's great advice. One of the things we're going to talk about on Friday in our last lecture is putting together scorecards, and that's going to be part of the advice for that, and the same can go for visual boards. Excellent point. Okay, Jim, you had a comment or question?
Well, I think, I've seen it in how it's implemented. we've had, usually it's assigned to someone or two people, and then the best way is where actually everybody has some input on it. So you break it up and you say, okay, we bring it all together, and you actually make it a team exercise rather than someone on the team.
Mm-hmm. Mm-hmm. Yeah, and I think that's kind of a standard point that we want to make with all of our Six Sigma projects is when we're getting to the control phase, this is when we really need to make sure that we're lockstep with our process owners and with the people that are in the process, because it's moving it from, okay, the team owns this to everybody owns this, and if we don't get that buy-in, it's going to die. It's going to die a death that's probably going to be quick, regardless of how good the solution may be. So yeah, absolutely, get people involved. Now, there's a couple of different ways I think that are some of the reasons why people use them. And I've got a couple up here that I think are kind of basic to easily communicate to ourselves and others what we're trying to accomplish and what we have accomplished. Sometimes people like to put a post for here's what we've done, not make sort of an action-oriented visual board. I prefer the action-oriented visual boards. And I also have this idea of it provides a rallying point upon which to organize and energize work teams. What I mean by that is, for example, I did some stuff at MassMutual, and by the way, MassMutual did this really well. So that's one of the reasons why I want to put them out. I wasn't, or put them out as an example. I wasn't the only person who did this. They did a lot independently. But with some of the teams I worked over there, we actually created things that were used in operations where the boards were, they would have their morning huddles every day to do their work assignments around these visual boards. That's great. It's like it's like the tribe coming to the fire at the beginning of the day and saying, okay, here's what we're going to do. Mark and Jim are going to hunt and so forth. All right. Shouldn't use that example, but anyway, you can see it kind of is in our past and maybe in our genes that we like to do that. But another great reason to do it is simply because it's a great show-off point too. So if visitors come, seeing visual boards is often just a great thing to show to show visitors what you've done to make improvements and what you've done to kind of sustain things. Let me show you just an example of something, and this is obviously a generic example, kind of going with the simplicity argument that Brad was talking about. Something that I've had in an area was they had a name of their functional group, they had a mission or vision, they had a process step of, maybe a process map of maybe 7 steps or less, going with Tracy's idea. They had work samples or photos. Here's what the one I'm remembering is one that was done in the food service and wholesaling. Here's examples of the things we're trying to find. They've had pictures of pallets where food had spilled over, or a truck where where a number of pallets had spilled over. A picture of where somebody had put the Clorox on top of the dog food or whatever, which is a no-no. You don't want to do that for obvious reasons. So they put pictures of things like that up there, and this is why we're here. We're here to protect the customer from these things happening. They had a few measurements, not 10, not 20, but they had a few. So typical ones are turnaround time, a % on time, % accurate, and you can see how it's going as time goes on. I've got control charts, but time series plots work well too, and then maybe a little section for current activities or initiatives, operations activity, inventory, maybe some current projects. Who knows? This is just an example of what you might consider putting on there. One other thing I wanted to point out is that a lot of times you can make visual boards prominent such that people have to physically update them, and the act of physically updating them connects them with the process in a good way too. So I love computers and I love stuff online and all that kind of stuff, but sometimes it's helpful to have a whiteboard that people plot points on and get excited about doing it because they have to do it with their hands, and it just gets them more involved. So I remember in one place where, I don't know if I told this story already, but when we were doing the work with the food wholesaler, worked with the team leader, and we went out shopping. You know, we bought the whiteboard, and we put this magnetic tape around, and they came up with the idea of using the magnetic tape to do the axes and the red line, and we got different colored markers, and it was interesting. You know, people would say, well, you know, I get to choose the marker color, and it was actually rather interesting, and it was all about, you know, getting a point from a page onto a point onto a whiteboard that everybody could see. And from day one, we started getting comments, you know, people coming by and saying, oh my God, I didn't know our quality levels were so bad. Well, we need to do something to fix this. That, you know, that's what it's all about. It really is. Really is. All right, so that's all I have on visual boards. It's a lot of sweat equity on this one, folks, but well worth it, I think. So I'm going to move on, and but if there are any comments or questions, love to hear from you now, and now's a good time to talk about it.
Yeah, Mark, I think one point, and you might have made it already, but what your visual board controls, shouldn't that be your key inputs that you identified way back in the define and measure phase?
It should be, but sometimes it isn't. Right? I mean, our projects are meant to be living, but you're right. I mean, very often, like you're talking about turnaround time and percent on time and percent accurate.
Right. Yeah. Whatever you identified as being critical to the process.
Yeah. In theory, those should be the same, and most of the time they are. Occasionally they aren't. But that's a great point. I didn't say that earlier, so thank you for bringing it up.
So one question I have is, what is your thought on measuring your X's versus your Y's at this point on your board? Your process inputs versus your outputs.
Ah, okay. So again, it depends on what the board's being used for. If it's a project board, right, then it could be even somewhat static. If it's an area board, like a process function, it's probably going to look a little bit more like this. And I think, again, primarily you're going to want if it's going to be public, you're probably going to want key performance measures that are at least viewed as mostly outputs. But you want them to be somewhat within your control, right? So that's, I think, the gray area about X's versus Y's. If you really have connected the X very solidly with a specific Y, then maybe you can put both. And then that can be a good, again, a good rallying cry. Maybe you want to put 2 panels in here. Maybe the top panel is our sort of our goal things, and on the bottom are our more specific goals. Like if this is sales, we'll have, you know, percent new members, and on the bottom we'll have, you know, phone calls that we've made. You know, something like that. But again, I want to caution that you do need to. Making a visual board is difficult, right? Because you want to design things where people are getting good feedback for things that are in their control. But on the other hand, you want to make sure that they're used, that they really matter. It's kind of like remember in the section in the book Bring Out the Best in People for pinpointing, where it said the first step in pinpointing is to make sure that we understand what are the results that we want. So pinpoint the results first, and only then pinpoint the behaviors that are going to get us those results. So, you know, it could be either. Be sparing on both. Did that answer your question, or sort of?
Yeah, that's really good. I like the way you tied the pinpointing and the behaviors into that as well. So I guess if you get to this phase and you're having trouble doing that, would that be a red flag to you that maybe you haven't tightened up the process as much as you would like?
Yeah, it could be. It really could be. That's a good point. I wasn't thinking of that when we first started this section, but that's a good I think that's a good takeaway from this.
That's good. Thanks.
You're welcome. Any other comments? That was great discussion. Okay. All right. So let's move on. As I said, there's stuff on process monitoring. And by the way, a lot of what was just commented on about X's versus Y's is talked about in process monitoring as well. The more that we can transfer the process, our understanding of the process from Y to X, from the outputs to the endpoints, the better that we're going to be at finding and mitigating problems earlier, at recommending specific solutions, and at managing that process on an ongoing basis. The process monitoring talks a little bit about that. It gives it in the context of control charts. So that's what's covered on slides 25 through 39. I'm going to cover that in a separate online lecture. So we're going to move to slide 40, which is on control plan. And I'm not going to talk a lot about this, but putting together a control plan, a control plan is almost like the opposite. I won't say the opposite, but it's similar to the control phase equivalent of like the charter. Control plan is kind of where everything comes together, and we put together all the pieces of the work that we've done to continue. And what I would say is I used to have oh, here it is right here. And I like people to remember this picture. Even though we've gone over a lot of difficult techniques, the statistics, by far the two hardest pieces of the project are define and control. I mean, this has been my experience at least. In define, you're struggling with what is it that we're really trying to do? How do we measure it? What do we mean by success? What does success look like if we hit it? And in control, what we're really saying is how can we get what we did to exist tomorrow and the next day and the next day and the next week and the next month and the next year and the year after that, so that we actually get economic value out of doing this and customer value out of doing this. Very, very difficult. The control plan is where it kind of comes together. Let's talk about, sometimes it's helpful to talk about what a control, what something is not. I want to talk about what a control plan is: an organized collection of the documents, files, procedures. I like to think of it as almost a user's manual for a process. If you can, it's got to be a living document so that people update it as it's there. Here are some of the things that it's not. It's not a tool to increase firefighting. If your control plan is just increasing firefighting, people are going to stop using it. It's not just a way to increase audits or add bureaucracy. It's not a list of next steps in the project, and it's not a place to include all your data, your reasoning, how great you were in managing the team. It's not a PowerPoint presentation. It's a living document that helps a process owner and the managers who work in the process keep the changes there and make additional improvements. Okay. It can be a to-do list, but sometimes it's a not-to-do list as well. If you're familiar with Gary Collins' Good to Great, he talks about that. He doesn't talk about control plans, but he talks about having a not-to-do list as well. Here are some things that I think in a control plan that almost every control plan should have. It should have a list of some of the key changes that were there, including any error proofing that you've done. It should have a monitoring plan. Which key outputs and key inputs do we measure? How do we measure? Who's responsible for doing it on an ongoing basis? It needs to have a corrective action plan. What happens when the process goes out of control? What do we do? Who do you call besides Ghostbusters? Okay. It needs to have a training plan. So Tracy mentioned this earlier. Very good that she did. It needs to have a training plan. Who gets trained on what? What happens when we bring somebody in? What training do they need to have? Is there periodic testing that needs to happen? Okay. Great example of this is when I used to work at Corning, we worked in fiber optics, and one of the things that we often did was we brought in technicians who were used to doing electrical repairs. Well, when you're doing fiber optic repairs and putting together fiber optic kits, all those electricians or all those electrical techs needed to be retrained because they were used to making nice, neat boxes. And I probably shared this with you a long time ago in one of the first lectures, but one of the things that's really important in fiber optics is not to make them tight and neat, because then you create cracks in the fibers and you have all sorts of problems. So people needed to be trained to sort of not do what was the right thing before. Documentation, what SOPs, standard workflow, flow charts, where do I store data, where do I retrieve it, which phone numbers are there, or nowadays, emails or text, I guess that would still be phone numbers. Maybe Twitter accounts need to be there. Let's hope not. I don't know, maybe I should hope so. Update plan, and this is kind of like one of the things I like to put in there. When is the control plan going to be revised and by whom? And then finally, what I think is a very nice thing to have is a single-page process summary of all that of what's in there. And I've got an example on the next page, but I've actually got a better one in the template that I gave you. So I just want to kind of show you the template. I'm going to not spend an awful lot of time on there, but here's the template that you've got, and you'll see it's got a number of different tabs. In Excel. Here's maybe the high-level header stuff, so the name, the date, the revision, when's the date for the next review. It says +3, 4, 6 months out, but it should have a specific date, who it's prepared by, who it's approved by, what are the key metrics, what are the key charts that we're looking at, who reviews it, how often, which charts are reviewed, who is going to meet, maybe even where we're going to meet. Anything that can kind of make it more that here's what happens on an ongoing process. Here's that high-level process map I think that Tracy was talking about. You might want to have lower-level process maps in there as well, but you probably wouldn't put that on your one-pager. Here's the monitoring plan. Again, just this is very specific about sort of which metrics are going to be monitored or what things are going to be monitored, any specifications, how you're going to do it, what chart there is, what the sample size is, who's doing it, and what happens if it goes wrong. Again, I'm just putting this out as a template that you might be able to use. Here's literally the charts that are put in there. So if you have a specific control chart in there, you might want to even embed it in the control plan. A troubleshooting guide. What happens when you're out of control on the plot here? So, for example, if you started out as in control here, and then all of a sudden you're out of control. What happens when you're out of control? Does it get logged here? What do you do there? Here's a training plan. Obviously, very incomplete here, and any changes that are made. So this is, like I say, I've used this with a number of different clients, and they found that it's a decent starting place for a lot of what's there, and much more tactical than the things that you'll find on the web for a control plan, which usually looks a lot like the monitoring plan. Which to me, if I'm managing a process with this, it's just not enough. It really is not enough. You might want to add in, if I were doing this, I might want to add in a tab that says, here's the documentation, stuff like that. Okay, so you've got that, and that's about it. I think that most people get control plan ideas. It's just, it's not easy to do, though. It's sort of, it's not grunge work. It's not drudgery, but it's work that's difficult to do. You got to stay focused. Here are just some guides on creating a control plan. If you've got a control plan and you want to create a structure that's similar to what we've got there, it shouldn't ever be created in a vacuum. Don't just do it yourself. It needs to be done with the team. Particularly, the process owner needs to be involved. Stakeholders need to be involved early. To Brad's point and to Jim's point too, if you're starting the control plan in the control phase, that may be a little bit late. you want to start thinking about the control plan even in sometimes the analyze phase and certainly in the improve phase. You need to be thinking about it. Key stakeholders need to be involved early. They need to review the plan. They need to know that it will be around. You may not be around, especially if you're a black belt. If you're a green belt, you can be around. But if you're a black belt, you may need to go to other places and run other projects. And guess what? If you own every control plan that you complete, if you own every project that you ever complete, you're going to have a lifespan as a black belt of about a year. You're not going to be able to do any more than that because you're going to own too many things and you're going to die the death of 1,000 duck bites. So writing a good control plan is one of the keys to being relevant, not to being somebody who becomes irrelevant over time, and also to surviving as a black belt, to creating something that people use. Very important to have a good control plan. All right. One process that might be there is draft up the control plan during an earlier phase, share it with the process owner or owners, and rework until you get it right. You know, chances are the first time you give it over, the process owner isn't going to nod for everything. There will be some changes that need to be made. Sometimes the measurements that you want to make may not be ideal. There may be some automated measurements or measurements that are much easier to get. They're good enough. It's much better to have a measurement that is measured, something that is measured and is pretty relevant, than a perfect measurement that nobody will actually will actually keep track of. So that's the general advice. Love to have any. Ooh, that was interesting. Love to have any comments or questions or additions to this. So any ideas that anybody has, please bring them up and let's talk about them. Okay. All right. I wish you luck on creating good control plans, and this is something, if you want me to take a good look at your control plan, I'd be more than happy to be a second set of eyes when you get to that point in the project, so don't be shy. Give me a call and talk it through. Use that template if you find it helpful. If you don't find it helpful, don't use it. But a number of my clients have found it helpful. Okay. Well, I've got about quarter after, and I'm going to move on, and I want to talk a little bit about optimization. So we've got two things left today to cover. I don't think we're going to get to queuing. Maybe we'll have just a short discussion on queuing on Friday. But I do want to talk about something that not a lot of folks talk about in this. And when I learned this, it was given the lovely phrase linear programming. And then I learned integer programming. And then I learned mathematical programming in general. And all that stuff sounds really esoteric, and it doesn't sound all that interesting or helpful. But optimization does. So I want to talk a little bit about optimization, and I want to show you how you can use Excel. You can use Excel to do a lot of things that are kind of basic optimization sort of 101 problems. So we're going to be picking up, this is slide 50 in your text. And so let's just kind of walk through this. I won't walk through every example. My goal here is to show you, give you a little bit of flavor for how this stuff works, and hopefully to get you kind of involved in it. So when we finish this, you'll be able to explain the fundamental aspects of optimization problems. You'll be able to use Excel Solver to solve linear programming, integer programming, and constrained optimizations. That just means you'll be able to optimize some things in key areas. And you'll be able to cite examples where you could use this stuff, which is really kind of the most important part. So first of all, let me black out the screen. I know you can look down at your books and know it, but I'd like to kind of just ask you, take 15 seconds. Let's do our old 15-second exercise. And I'd like you to brainstorm, write down on a sheet of paper what are some ideas. When I say optimization, what does that mean to you? What does optimization mean to you? What is optimization? Okay, so just take a moment and think about that. Okay. I guess I'm going to put somebody on the spot. Patrick, I'm going to put you on the spot a little bit. I'm going to ask you, in your words, what would you say optimization means?
Doing the most with the least.
Doing the most with the least. I love it. Okay, so doing the most with least. Okay, excellent, excellent. Does anybody have anything that we'd want to add to that?
Yeah, I think when I think of optimization, depending on the context, a lot of it is the point at which further effort will reduce the output.
Okay. I'll say worsens, right? Because sometimes more is
So, like an
less.
example, you can do marketing to a point, but any additional marketing, the cost of the marketing is going to exceed the profit from the additional sales. So you're past your optimal point there.
Got it. Okay. Good. 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 One of the things I guess I would point out in a lot of modern things, we talk about DOE, and DOE is a way of optimizing, but in this particular section, we're going to take we're going to essentially assume, in this case, we're going to assume that we have sort of some fixed constraints. So we're going to consider some fixed constraints, and we'll find out. We'll say, well, what is the best use of resources, or what is the best given these constraints? So that's what we're going to consider in here. Okay? So I'd like you to take now, if we say, I think all of these are great examples here, doing the most with the least, getting to that point where further effort will essentially worsen the output or will push us beyond a trade-off place. And what is maybe the best that we can do given our current operating or given operating constraints? Okay, and what I'd like you to do is to take a couple of now let's take 15 seconds, and I'd like you to give examples of optimization in your world. What might you need to optimize in your world? Okay, 15 seconds, just write them down. No wrong answers here. Write down one or two. If you got one or two, that's good. If you got three, that's really good. If you got four, that's good, good, good. I'll shut up now. Okay, let's see if we can go around the room and get some examples. So I'm going to start with Sue. So Sue, what's an example of something that you could or have optimized in your business?
I was thinking a call center. We want to be able to answer the calls as efficiently as quickly as possible, but not keep customers waiting, but have high.
Okay, so minimize wait time.
Right.
Given maybe fixed labor hours, right? I mean, I'm paraphrasing this here, but there may be other constraints. So the point is, we're trying to minimize something, in this case, customer wait time, given some constraints in our business. Good, that's a great example. All right, Jim, what's an example from your world? Okay. Let's move on. Looks like Jim has either got the mute button on or isn't with us for just a moment. Let me move to
I'm here.
Patrick. Oh, hey, Jim.
I'm sorry.
What's
I didn't want you to hear me. I didn't want you to hear me eating my lunch. Minimize downtime.
Minimize downtime. Okay. What constraints might exist there?
You might have outside variable like weather.
Okay. Given weather constraints. Might be difficult to quantify those. But we could do it. We could say, let's minimize our like if you were if you were my friend Tony Nestor and you did outside hiking tours, and suppose you lived in Michigan, you might want to minimize your downtime given weather constraints. You might quantify that by saying, given the constraint that we have to stay in Michigan, or given the constraint that we have to have less than, we're willing to spend less than $5,000 per class on whatever. Okay, good example. Let's see, Patrick, what's an example that you came up with?
Turnaround time on lab results to the emergency department.
Given what? Oh, okay, got it. And what might be some constraints that you would have on that? You're trying to minimize that turnaround time from the lab, or of the lab results.
The time it actually takes to run the test is a big constraint, because you can't go any faster once you put it on the machine.
Okay. Given machine time. Okay, machine cat. Okay, got it. Tracy, are you still with us?
Yes.
Okay, great. What's an example that you've got?
Maximize ED patient visits per room.
Oh. Right. Given maybe a constraint of, what would be a constraint that's there?
7 rooms.
Yeah. With equal of 7 rooms.
Right. The constraint is that's all the rooms we're going to get.
Got it. So this is a very specific example, a very good one, and there may be many more constraints. Anyway, okay, so let's see. Shani, what's one that you came up with?
That for trainings that we need to get people to like 90% or better in scores or in actually doing the tasks, but we need to do it within 5 days.
Okay. So we will do better if we instead of saying something like we need to get people to a goal, we would try and maximize. You could do it this way. You could maximize the number of people, or the percent of people, probably number of people greater than 90% score, whatever that means. That's my objective function given less than or equal 5 days of training.
Okay.
That works. Right, and there could be other things, right? Also constrained on class size and all the rest. Okay, last but certainly not least, Brad, what was an example that you came up with?
I think one of the things is the batch size for food in our dietary is, the bigger it is, the lower the per pound cost, but the higher our odds for spoilage. So we're trying to balance those two factors.
Okay, so one way of doing that would be sort of to minimize the cost of this, given some constraints on spoilage.
Correct.
On spoilage, and maybe in this case, the adjustments that you'll make are to the batch sizes. And maybe there's other things too, but you may be able to adjust batch sizes to do this. All right, so what I want to do is I want to show you basically how you can do this in Excel. You'll have, first of all, I want to ask, has anybody ever used the Excel solver before? Okay, nobody on the call. So even if you've done linear programming before, this is going to look a little bit foreign. And yes, there are some tricks, but I just want to introduce you to this just so you know it's out there, and that oh yeah, that's right, that you can do this. So and you can learn more about it. So if you want to, you can go ahead and open up this file, Optimization, I'm going to show you basically how this works for the given for some of the given problems. So here's an example of optimization. So here you've got a computer manufacturer that makes peripheral equipment like mice, keyboards, and USB hubs. Okay, they might want to maximize their monthly profit given some constraints, and the constraints might be, well, we only have so much monthly demand. And we can only make things so fast. And here's what the profit per unit is on these. Some other constraints might be we only have 10,000 labor hours available in a month. We're not going to have an additional labor spend. And we only have 1,700 production hours available per month. So that might be, those might be some constraints on here. Okay. Now you'll notice that you need to be able to create a table like this with some assumptions. So we're assuming a decent amount. Instead of going in the book, what I'm going to do is I'm going to do this in, if I can hit the escape button somehow. Somehow I can't get out of this. There we go. Got out. Okay. So I'm going to go into this optimization book and a notebook. I don't think I need this one anymore. Okay, and this is on the computer tab right here, and I'll show you what you need to do. So, and to do this. So this uses something called the Excel solver, and it should be available free. You can get it by going to, if you go to the tools, add-ins, you may have to add the solver. And you may, if you're downloading it or you get it from Microsoft somehow, you may have to navigate to it and add it in by hitting the Browse button and then walking through. This folder is empty, but you can navigate to where it is, and so forth. But let's just show you how this would work. So the Excel solver basically says, what would I do if I had, if I started with these constraints, and these were my demand hours? Well, just think about this for just a moment. If you wanted to maximize the profit, what I've got down here is I put together a spreadsheet that would say, well, if we made this many mice, 12,000, which is the maximum market demand, and we made 20,000 keyboards, and we made 3,000 USB hubs, this would be our profit, $289,000. Now the question is, can we do this? Oops, I'm sorry, no. Let me put that in there. This would be our profit, $328,700. And the question is, can we do this? Well, given the constraints right now, the monthly labor for each of these would end up being these numbers right here, and that adds up to 10,560 hours. That's above our constraint. And also, it would take up this much production time. Okay. So there's lots of different algorithms, and if you want to know how calculus comes in handy, it's all calculus behind here. But I'm just going to show you how to use Excel so that we can let Excel find the solution that satisfies these constraints and maximizes this number given those constraints. Okay, so let's go ahead and do that. So I'm going to use solver, and first of all, solver needs a target cell. The target cell is what you either want to max, min, or get to a target. Okay, so in this case we want to maximize that, so I've got that checked. And then it says by changing cells. So these are the cells that we want to change. Okay, these right here, we'll change these until we find something that satisfies these constraints and maximizes this. And then we need to add our constraints in. So let's talk through what some of the constraints would be. So the first thing, and you know what, I'm going to go ahead and delete these just so that you can see me add them going on. So the first constraint would be that we want all of these things right here. I'm going to add a constraint. I want all of these guys right here to be less than or equal to the monthly demand, which is right here. Okay? Hopefully that makes some sense. So I don't want to exceed demand because then I'll have obsolete inventory. So I'm going to add that constraint. I'll click the Add button. Secondly, I want this cell right here to be less than or equal to this 10,000. Now notice I put that in. I could hardwire in 10,000, but I'd rather put it right here. Okay, and I'll add that. And then finally, I want this to be less than or equal to the 1,700. I'll add that. Whoops. Okay, so I've just added those constraints. And once I've got that, I'm just going to let it rip. So I'll let Excel rip. And voila, it found a solution, which happened to be the one that was already programmed in there. And this, you can rest assured, is the maximum given these constraints that we can do. If we do any more any more of these things, we're going to exceed some of the constraints. Notice that we're right up on one of these constraints. So if I go to 3001, I actually exceed the this constraint right here. I know it didn't register, but that's only because of significant digits. We do it, there it is right there, 0.04. See that? That's greater than 0.00. Okay? So that's what's going on right there. So far, did that make some sense? Hopefully it made some sense. Now, obviously, in a real situation, what many people would do is simply do trial and error. Let's set up something like this, and let's see what maybe maximizes this, and so forth. So that's kind of one way of one example of how this works. Let's maybe take an example that makes a little more sense in your worlds, and let's do work.
I had a question about that last one.
Oh, sure. Mm-hmm.
Does it in any way prioritize one of those sections? Like, it's going to allow you to get more keyboards than hubs, or or is it each one of its own calculation?
It does not prioritize what it does first. It finds the maximum.
Okay.
Given the constraints. This is the max. If we went to 11,999 here and went to as many
Oh, got you.
3,001,
Okay.
it's not going to be, this number right here is not going to be as big as the other one was.
Cool. That makes sense.
Okay, so it maximizes. Now, by the way, does it say you have to do this exact schedule? No, it just gives you maybe you can help build an operation or management plan that will help get there. Let's do another place where this can be used very often is workforce scheduling. So let's do this one, for example. I'll go through a couple of the examples in here, and I think you'll see there are some tricks. Okay, there's no question there are some tricks, but hopefully you'll see the value of doing this. So here, suppose we've got a care delivery center and it's open 7 days a week. The number of workers needed each day to meet patient demand. So we want to make sure that we have enough people on staff to meet patient demand. And let's say that these are the numbers. So it looks like we need fewer people on Friday, Saturday, Sunday. We need more people on Monday, Tuesday, Wednesday, Thursday to meet demand. However, we also want to schedule people on 5 consecutive work days. So we want to give them some continuous days. We want to schedule 4 and 1 or anything like that. In this case, let's take a look at the constraints. So in this case, we're trying to, what would we try and do? Here we're trying to minimize the number of workers that we need. Oops, the staff, right? So we're going to minimize the staff. But we also have a constraint where we have to meet these numbers that are given right here. We have to have this many people covering the patients, and we want to give people a break, and we want to have people work 5 consecutive days. All right. So how could we rearrange the schedule to do that? Well, first of all, let's take a look at the spreadsheet. So I'm going to take a look at the spreadsheet right here. So here's one of the ways I did this. Was I said, okay, here's our constraints right here, and then if I have, if I start somebody on a Monday, like let's say these are the people that are started on Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Okay, so I start 10 people on this, and 0 people start on Tuesday, and so forth. So the people that start on Monday would work Monday, Tuesday, Wednesday, Thursday, Friday, and then they'd be off Saturday and Sunday. Okay? Hopefully this makes some sense to you. Okay? The second people, looks like nobody started on Tuesday, but if we did start somebody on Tuesday, let's put a 2 there, they'd work on Tuesday, Wednesday, Thursday, Friday, and Saturday, and they'd be off on Sunday and Monday. Okay? All right, so the challenges here, like what if you started everybody to say, well, I want to meet the demand, I'll start everybody 16 people on Monday and 0 elsewhere. Obviously, you're going to meet the demand on Monday, Tuesday, Wednesday, Thursday, Friday, but you're going to be short-staffed on Saturday and Sunday in a big way. So you start to think about, okay, so what if I shifted some of those people on Sunday and so forth, right? And you can see that this would be a bear to find, well, what would really be the minimum that we'd have? It's easy to say, well, let me add another 10 people here. Not 100. That would be really overstaffed. How about 8? And, oh, that covers me Friday, Saturday, Sunday, but wow, I'm really overcovered on a lot of these days. I guess maybe I'd just go, instead of that, I go to this. And I don't know, maybe this is right, but I'm really overcovered on these days. How do I find that minimum or maximum? So we're going to let Excel do it by using the solver. Okay? So let's go through that. So what I want to do in this case is I want to change these cells, and I want to find what is the optimal configuration that tries to minimize this given this constraint right here, and that these constraints are met. Okay. So here I'm setting my target cell right here. It's a minimum. And I'm going to change these cells. I actually gave these cells a name called num workers. And let me delete all the constraints so you'll see me doing them. You've actually got them in the book so you can go back, or in your file, so you can go back and get them exactly. So we're going to change these cells, which happen to be num workers, and we're going to put in the constraints. So first constraint I'm going to add is that these numbers down here need to be less than my greater than or equal to these right here. So let's add in a constraint. These need to be greater than or equal to my minimum staffing requirements. So I'll add that. Okay. And the second thing I want to do is I want to make sure that these are all integers. That these, I'm sorry, actually, this will be instructive. So what happened if I just let this go and I say, okay, well, I want to minimize this number subject to the constraint that these need to be less than or equal to this, and just let it go. Okay, so hopefully you see a problem here. The problem is it started with, it created 6.5 people starting on Monday, which is not helpful. And it had some people, it had some negative people in here, which is also not possible. So let's add a couple of more constraints in here. And this is kind of how you do it. You let it rip and you see do the results make some sense, and check it out. Okay, so one of the other constraints that we would need to add in would be that I only can have a whole person. So this is an integer. Okay, so I'm going to add that. Another is that this is greater than or equal to 0. We'll add that in. Okay, so now I've got those in there. I'll go ahead and hit the solve button. And there it is right there. So it says that this is one solution. There may be other solutions, by the way, but this is one solution that it found. And you can try out different solutions. None of them are going to be better than 18, but you can try out different solutions. Like if you start from a different starting point, Excel may find a different solution. Like look at this, it found 10 starting on Monday, and so forth, but it also was 18. And you can see you're a little bit overstaffed on Monday, but and you're definitely overstaffed on Friday, but it turns out that this is the minimum solution given this given these constraints. So anyway, it's a nice little starting point where you can do this sort of thing, where you can find the minimum or maximum of various things. Okay? I'd like to do one more. Well, first of all, I guess I'd like to take any questions that you had on this. I know this is a little bit complex, and being able to set up this table is a bit of a trick. Okay, I'm going to do one more here, and we'll do the example that's given on that's going to be given in one of your exercises, which is in capital budgeting. Okay, so this hopefully will be one that rings very true, especially for people that are master black belts or going to be master black belts, or people that are management. Let me just say COOs. This ought to be something that's important. And how do we choose maybe from a set of projects so if we have labor constraints and cost constraints? Here's the background. Suppose that we have a list of potential projects, and what we've got is the net present value or the return on investment or some financial measure on all these projects, when we somehow have the estimates for the cost, the return, and the amount of labor that we would need, and we're given some constraints on that labor and cost. How can we maximize the return? How can we maximize the return and meet those constraints? So let's take a look at that. So in here, what I've got is I've got the NPV for 20 projects. Okay, the net present value for 20 projects, and it's given right here. And for example, for project 1, here's what the net present value is going to be. Here's the cost year 1. Here's the cost year 2. Here's the cost year 3. And here's the labor that I need to put in year 1, year 2, year 3. Okay? Hopefully you all understand that. At the top are the limits. So for example, maybe these are in thousands of dollars. So if no matter how much the projects are, I've only got a budget of $2.5 million to spend in this area in year 1. And in year 2, maybe next year, I've got $2.8 million. In year 3, I've got $2.9 million. Okay? And but each year, I've only got 900 labor units to do this. All right? So how do I pick and maximize the amount of return that I get given these constraints? All right? Well, one way to do it is to either put all ones and zeros. If we were going to do every project, we could do every project here. And what I'm going to do is I'm going to sum these up using a function called, whoops, I'll make this really big. A little bit of Excel tutelage here. If you sum product, it's a great function to know if you don't know it. And I'm going to sum up the product of these. Okay? So what I'm doing is I'm multiplying columns B and D individually. So let me just shrink this down just a little bit so you can see what's going on. So for example, if I don't do project 1, this would be a 0 here. And you'll notice that $928,000 comes out of C25. Bam. Everybody see that? So if I could do every project, I'd get this. Let's see if all of this is doable. If I could do it all, that'd be great, because then I just say let's do all the projects. Let's just see if we go into cost overruns or labor overruns. So again, sum product of this array and this guy right here. Okay. So it says, uh-oh, already I can see I've got cost overruns. I'm going to use a little trick here and bind these numbers. Okay. So I can copy this across. Okay, good. So this is what happens if we run all the projects. Clearly, there's cost overruns every year, and there's labor runs every year. So I cannot do all the projects. So what I'm going to do is I'm going to let Excel change all of these I'll put those as yellow. And I want to try and maximize this guy. I'll put that as green, right, for money. And I'll put my constraints right here. Those are, whoops, not in green. I'll put those in, say, blue. There we go. So blue are my constraints here. And let's see if we can change the ones and the zeros. Let's put them all at 0. I like to start from 0. Let's see how far we get in terms of maximizing this. Let's see what projects we should run, or what would be something that maximizes that. So let's go ahead and use the solver. Got to go to the right thing here. Oh, okay, yeah. I want to clear all, reset all. Okay, so in this case, let me kind of go around the room just to make sure we're kind of getting it. So, Shani, what would be the target cell here in my example?
The yellow column?
No.
No. Your target, meaning what it is the green?
Yes, that's right. So it's C25.
Sorry, target green.
That's okay. That's all right. So C25, or I guess I'm sorry, I said C25, D25. I don't know how to read. Is there? Okay, good. Patrick, now we have something to. Should it be a max, min, or a value of here?
Maximization?
It should be max, so we just leave that as is. Good. Now let's go to this one. Sue, by changing cells, which cells should I select? Sue, are you there?
Sue stepped out.
Oh, okay. So Brad, I'll ask you. So what cells should we select here?
You want to change the yellow cells.
You got it. Okay, so we want to change the yellow cells. Okay. Now, subject to the constraints. Tracy, what is one constraint that we have on here?
F25.
F25, excellent. And in fact, I'm going to kill a bunch of birds with one stone, and I'm going to say that on the bottom here, F25 has to be less than what value, Tracy?
2500.
Yeah, you got it, and it's F2, right? So we'll put in that. And the reason why I'm saying F2 instead of 2500 is that what if we wanted to play around with that a little bit later, then we wouldn't have to change our solver.
Okay.
Okay, so I'm going to add that one in. That's great. So we'll make this one less than or equal to this one. And we'll just add that in. Okay, so that's one constraint. Jim, what's another constraint?
Would be the labor. I guess it would be I-900.
Okay, I-25. Oops.
Oh.
Oops, that's okay. Let's add one in. So it'd be cell I-25 is less than or equal to which cell?
I-900.
Okay, that's I2. I2.
I-2.
Yep.
Okay.
Got it. Okay, add. All right, so we've got these. I'm going to just show you a shortcut. We'd also have to do, say, this one less than this one less than this, and all that kind of stuff, right? I'm going to show you a shortcut to doing all this. So let me just, by the way, everything that you said was fine, but I'm going to add all of those at once. So I'll let the cell references here be less than or equal to the cell references there. Hey, wait a second. I've got to click on the right things here. There we go. So notice that when I've added that one, it adds a constraint that all of these have to be less than or equal to all of these. Okay? So it's just a shortcut, and you would have gotten it the way that you were doing it. Let's go ahead and let it rip and see if it comes up with a solution that's reasonable, okay? It turns out there's a couple of other constraints, but it's not obvious. So let's just let it rip and see if we can figure it out. Click solve. Bam. All right. So I'm going to click OK here to keep the solution, but I think we're going to see a problem here in just a second. So it says here...
So yellow needs to be a 1 or a 0?
Ah, I love it. Okay, so we need to make sure that this is either a 1 or a 0. Stupid me, I didn't put that in. I like this number. It maximized it to like several trillion, but or beyond several trillion, whatever is the next one there. but we need ones and zeros. So let's go ahead and put that one in. That's a good one. So let's add that in. And so how would we add in ones or zeros? It has to be a 1 or a 0. Any thoughts?
Highlight the yellow for the cell reference.
Got it? Uh-huh.
And then does your drop-down box have a integer or numbers or anything?
It has integer, and it has another thing called bin here.
Huh.
Yeah. So I heard somebody else say something.
So like no greater than 1, no less than 0?
Yeah, so there's a number of different ways we can skin this cat. One way to say is it would be less than or equal to 1. We could add that. The same thing has to be greater than or equal to 0. We can add that. And the same thing has to be an integer. It can't be a half a project, right? It also has to be an integer. And we'll add all 3 of those, and there we go. And that's going to give us an answer. Another way of doing it would have been in Excel has these shortcuts. We could have said this whole thing was bin, and that just stands for binary. It has to be a 0 or a 1. But again, those are shortcuts that you can learn by clicking on the help here, and it'll tell you about it. But this should get you quite a bit. All right, I'm ready to let it rip again. And I'm going to hit the solve button. Now, this will give you an idea of how much sometimes Excel has to struggle to get this. So it's actually trying, all these different trials. You can see it's up to 57, 58. Uh-oh, it's slowing down. Uh-oh, is it going to end? This was much faster when I did it before class, by the way. Uh-oh. Okay, there it goes. Now, Excel does stop every once in a while if it finds out that it's got a problem. But there it is. It found a solution where here are the projects that we should run to maximize the ROI and to live within these constraints. So again, this could be something hopefully that you would find to be pretty useful in setting up which projects should we run. This might give you a really good starting point to say here's what we could do. There's a couple of additional in the problem that's in there. There's a couple of additional things. I just want to show you how you can do this. The first one would be, what if project 3? What if we did 4, we had to do project? I'm sorry. If we did 3, we had to do 4. And everybody's got these. Like a project that might be an improvement to a call center, but we can't. In order to do that, we also have to do something first. Like it assumes that we have to do this. We have to have this particular software before we make this improvement. How would you do that? And how would you add that constraint in there? Well, here's one way of doing it. I could fix this so that 3 has to be less than or equal to 4. Well, what does that mean? Well, if we do project 4, it doesn't mean that we have to do project 3. But if we do project 3, we have to do project 4. So if we can have a 0, 0, we could have a 0, 1, we could have a 1, 1, but we couldn't have a 1, 0 like we've got right here. And one way of doing that would be to add in the constraint that this has to be less than or equal to that cell. I'll add that in, and now I'll resolve it. And it still takes a while here. And go ahead. It did come up with a solution that involved running project 3 and 4. So it maximizes it. You can see that that's a little bit less than it was before. It was 9,200. So 9 million. It went to 9.2 million to 9.1 million. Let's see. What if we had only projects 1 through 10? We were only able to select 4 of those for some reason. Like this is one operational area. Like let's say that this is operational area A, and this is operational area B, okay, in the green, and that operational A, the max, and op B, the max in op A is 4, okay. What if that were true? What if the max were 4? Now here I'll put in just the sum of all these guys right here, and just for giggles, I'll put in the sum of these guys right here. And but there's a constraint that say the max that this can be is 4 in operational area A. How would I add that in? Pretty straightforward. I add in these guys have to be less than or equal to 4. Okay, and go ahead and let that solve. And there you go. You'll see that this, whoa, something didn't work there. Something didn't work. Oh, I see what I did wrong. I see what I did wrong. Let me try this again. I'll make mistakes here. Delete that. Add a constraint. Try again, Mark. This cell has to be less than or equal to this cell. And you'll see now that at this point, this cell is the sum of all of the first 10 here, and you'll see that that comes up. Now to be 4. There it is, and it says you run project 7, 8, 9, 10, and these guys, and you'll get an ROI of 8.9 million. A little bit less, but you've taken into account now that you can only run 4 projects here, and the rest of them have to come from operational area B. Okay, so lots of different things that you can do with scheduling, lots of different things that you can do with project selection, and things like that. So hopefully it's a pretty cool tool, and I've given you a flavor of how to use it, and you won't be shy about maybe trying it out. Okay, so there's a couple of more examples in there. There's an example of lawyers optimizing resources, minimizing the total number of hours. You think maybe lawyers, they'd maximize it, but I'm not going to make any lawyer jokes here. Too easy. And then there's an example of, there's also an example in here of coaching and times to minimize, finding the best team for a relay of backstroke, breaststroke, butterfly, freestyle, minimizing the relay time, putting together an optimal team. So you can see that this has some pretty broad application in business, and there's a lot of examples that are there. But you do need some very specific numbers to put in for some constraints. Often a good place to start. All right. Before I move on and do a little bit of summary for today, I guess I'd like to have any comments or questions that you might have. Take those. Okay. Hopefully you're seeing some application of this. Even if it's a little bit tough, you can always call me and say, hey, I'm putting this together, and how would you do this constraint, and so forth. Happy to help. Okay? All right. Well, it looks like we didn't get the queuing theory. I would like to spend just a little bit of time covering that on Friday. I will post a lecture on queuing theory. I hate that I titled this as queuing theory, because queuing theory is very important. Queues are all over. Queues are lines, right? So what we cover in that section is another very powerful way of looking at how I can answer all sorts of questions around how can I minimize the time people wait in line, how can I maximize my utilization of people in the call center or my hospital beds, how can I minimize the probability that the queue is empty or full. How can I meet performance guarantees? Like 95% of the time, I will answer the phone, or I will answer the phone within in the first minute. So queuing theory is a very powerful way of doing that, and I will cover that fully in the an online lecture. I'd really like it if all of you could could give that a quick watch. I'll try and keep it short, less than a half hour, so you get some examples of what's there, and that's it. So just to kind of quickly wrap up. To quickly. Oh, now I've got this. To quickly wrap up here, we did talk about the control plan. We did talk about control plan, or the control phase, and we talked about several tools. We talked about error proofing. We talked about visual boards, and we talked about 5S just very briefly, and we talked a lot about control plan, what to put in a control plan, maybe even what not to put in a control plan. And then we covered what I called optimization, which is called linear programming. In management and operations management, it's called linear programming. And this is about maximizing or minimizing things given constraints, and we all have problems like that in our processes. So this can be a very powerful tool in this, and this we use the Excel solver, which is free. I didn't have to pay a dime for that tool. So hopefully you found this lecture helpful, and happy to take any questions that you have now, and I'll stick around for a little bit. I see we're a couple minutes over, but I'm gonna stop now, and but I'll field any questions that you have. Okay, so have a good rest of the week, and short week, and we'll see you on Friday.
Thanks, Mark.
Okay, looks like there are no questions. So Shani and Jim, Sue and Jim, have a great rest of the week, and we'll talk to you on Friday.
Hey, wait a minute.
Oh, okay.
I want to discuss Moneyball.
Oh, Moneyball. Okay.
Outstanding.
Oh, you love it, huh?
Yeah, I loved it. As a matter of fact, I rented it, but I'm going to buy my own copy. I loved it.
Oh, you saw the movie?
Yeah.
Oh, cool. Yeah. Yeah, excellent. Yeah, it's great stuff. Great stuff.
Yeah, the only thing I can say negative about it is there's no way Brad Pitt should have been nominated for an Academy Award, but I'm glad that.
Well, what do they say? He's a character actor. He's a character actor trapped in a leading man's body.
Yeah, but the young man who played the statistician, he did get an Academy Award, which I thought he should have.
Yeah, Jonah Hill. So Jonah Hill, I think his name is.
Yeah.
Yeah. So how do you like that? A statistician actually wins the Academy Award. How cool is that?
Yeah, that's great. But the elements in there. There was of course they count everything in baseball, and the whole I guess revolution of bringing statistics to baseball. But the other thing, there were other elements in there that I thought were really, really great, where he teaches the guy how to fire somebody.
Yeah. Yeah.
And I've always and I've had to fire people many times, and it doesn't get easy. It's still gut wrenching for me.
Oh yeah.
And because a lot of people. Yeah, and I thought that was interesting. We talked. He says to all these old seasoned scouts, okay, this is a new season. Here's the new guy, and this is how we're going to do it. no buy-in, just jams it down their throat.
Right.
I mean, there was some really, I mean, outside of the statistics, the whole, I mean, it was like a tutorial for Six Sigma, how not to do it.
Yeah, I think a lot of that had to do with, I mean, it was a movie. In the book, they really talked. Michael Lewis talked a lot about the culture change that happened, like saying, the whole reason for living for a lot of these scouts was to be in Florida and at the right high school game or wherever, right, in North Carolina or in Michigan on a in March, seeing this icebound game where they find that one pitcher who throws that 95-mile-an-hour fastball, and they see a half inning of that guy and say, this is the diamond, this is that guy that we know. And there's this whole lore of finding that kind of stuff, and between there and the numbers guy saying, you know what, we have a much better bet and we win more often if we use data from college people, because we just have a lot more data, we have a lot more experience with them, and it turns out that we're better able to predict whether somebody's going to win or not.
And the scouts. Yeah, the scouts are operating off of that. Even a blind squirrel finds a nut once in a while.
I like that.
Yeah. Or a blind pig finds a truffle.
Right.
Yeah, but more often than not, he goes hungry, he starves to death, and that's what people don't see.
Yeah, that's true. Oh yeah, my favorite one is actually of nature is the sea turtles, right? So if you think about it, it turns out that something like 1 out of every 100,000 or something like that, depending on the sea turtle, but 1 out of 100,000 eggs that's laid actually becomes an adult sea turtle, and that's a tremendous loss rate. And it might be okay for some nature to do that, but sea turtles aren't doing very well.
Yeah, and that may be one of the reasons why they live so long. So they have, but nature has a way of compensating for these things. But the other interesting thing in the movie was here's this guy, Brad Pitt's character Bean, who's got 5 out of the 5 tools that the scouts are looking for. Right. And he gets he gets out. I mean, he doesn't have a career.
It turned out he wasn't that good.
Yeah.
Yeah.
What was it though? I mean, so the scouts, the statement was, usually we're thrilled if we get 3 out of 5. You got 5 out of the 5. How can you have 5 out of the 5 skills that we're looking for and not make it in the majors? I mean, what was it? Was it his confidence? What was it?
Right. Well, that led to that whole thing of saying, well, okay, so it must mean that there are skills that we are not valuing that are important in predicting success. And if we can figure those out, we will have a huge advantage over everybody else who's using these 5 skills. And it turned out, one of those skills, as you know now, having seen the movie, is the ability to not swing at a pitch. Because they said that, that's something, you can teach power. You can teach people to become power hitters over time. And look at, there's the whole steroid thing going on. But, look at Barry Bonds. When he started, he wasn't all that much of a power hitter, but when he finished, he certainly was. You can say the same stuff about the steroids, and I think that there's some truth to that, more than a little.
It's true. I mean, there's a great saying from another baseball movie, which is A League of Their Own, which is women in baseball, which is, I don't know if you saw that one or not, but
sure.
she's talking to her little sister, and she, says, lay off those high pitches. You can't hit them, and you can't lay off them.
Yeah. Yeah, it is very hard to develop that good eye, the eye not to swing.
Yeah, and so, but there was just I want to watch it again.